Hello and welcome to our discussion on game theory. Today we'll advance onto unstable games. Now till this point we have talked about stable games. What happens if I come across a stable game? First thing, what is a game? Game is a competitive situation where one person's gain is other person's loss. Two-person zero-sum game. There are only two players and one person's gain is other person's loss. So this is two-person zero-sum game. In two-person zero-sum games, we saw that a matrix can be built to represent perspective of one player. If I put a 10, if I say that I have gained 10 units, in two-person zero-sum game, it obviously means that the other player has lost 10 units. Now, in order to represent this plus 10, minus 10, we built a payoff matrix. In payoff matrix, we had a row player, we had a column player. And last time when we met, we saw that the column players selects the minimax strategy, decision according to minimax strategy. Row player takes his decision according to maximum strategy. This is what we talked last time. Now, up till last time, we took only stable games. But what if we come across an unstable game? So today we'll see how to solve an unstable game. What happens if you come across an unstable game? Let me put up a question over here, a game over here. I will start from this side. Suppose we have this game. As soon as you get a game, first you should check for stability. Is this game a stable game? How do we check for stability? Look for a saddle point. How do I look for saddle point? By taking minimax decision for column player and maximum decision for row player. As soon as you get a game, check for stability. How do I check for stability? Through saddle point. How do I search my saddle point? By taking minimax strategy for column player and maximum strategy for row player. Minimax, maximum, maximum, minimum, 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 maximum. Both 14s are pointing at same point. So I say that it is a stable game. Saddle point is at R2, C2. Strategy for R is R, 0 and 1. Strategy for C is 0 and 1. Value of game is the value of saddle point, that is 14. This is how we solve a stable game. I hope you are having a pen and paper. I'll put up a question, you pause the question and you try to solve that question. You try to solve this question. As soon as you get a question, what is our sequence? Look for stability. If stability is there, look for saddle point. How do you look for saddle point? By taking minimax for column player and maximum for row player. This is the algorithm that we have learnt up till this point. This is the question. Please solve it. Pause the question and solve it. Maximum, maximum, minimum, 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 maximum. Now, first time ever we end up in a situation where both minimax and maximum are not pointing at same point. This 10 is pointing at some other location, this 9 is pointing at some other location. What is the saddle point? When our row selection and column selection point at same point. My row selection is 14, my column selection is 14, and incidentally both are pointing at same location. This is a saddle point. This is a stable game. This is a stable game. Saddle point is at R2, C2. Strategies are 0, 1 for row player, 0, 1 for column player, value of game is 14. This is how we proceed. But this time, for the first time ever, we are stuck in a situation where row is pointing at 9, some other location, column is pointing at 10, some other location. So this is first time we come across an unstable game. This is first time we have come across unstable game. Now, there are two ways to solve an unstable game of size 2 by 2. Now see, game size can be anything. It could be 2 by 2, it could be 3 by 3, it could be 3 by 5, it could be 7 by 2. Any size is possible. But we'll start with the smallest possible game and then we'll expand to the larger scenarios. The smallest possible game is an unstable game of 2 by 2. There are two different methods to solve this. We have Odomant method and we have algebraic method. Now, generally the algebraic method comes first. It is sort of complex, sort of inferior as compared to Odomant method. And obviously when we study 10 different techniques, the first one is inferior, then an advancement over it comes in second technique, third one is best. But as we move ahead, the techniques get better, but the complexity also increases. As you move to your fifth technique, it is better than the previous four, but it is more complex. This is a general rule. So here also what is happening is that algebraic is the first method, but it is not so much appropriate. It is a bit more complex. It is a lengthy process. So we'll leave it for now. We'll start our journey with Odomant method because it is important for us to understand certain calculations. So if we understand those calculations, then we can go to algebraic method also. So for now, we'll stick with Odomant method. So unstable game of size 2 by 2 can be solved using Odomant method or can be solved through algebraic method. For now, we are only studying Odomant method. So now I can write down my complete title as Odomant method to solve unstable game of size 2 by 2. Odomant method to solve unstable game of size 2 by 2. So this is an unstable game of size 2 by 2. Why is it an unstable game? Because both row selection and column selections are pointing in different directions. What is Odomant method? A very simple method. We have A1 and A2, B1 and B2, 9, 10, 12 and 8. Odomant method says take the difference of a row and write it down against the other row. Take difference of this row. Now when I say difference, difference always means larger minus smaller. It doesn't really mean if it is a -2, it is a +4, it is a 9, it is a 10. No. You pick the larger value. Different is always larger minus smaller. Take difference of first row. What does Audement method say? Take difference of first row and write it against the second row. Take difference of second row and write it against first row. Take difference of first column, write it against second column. So, we will take row and column differences and write them down against the other one. So, difference of first is larger minus smaller, 10 minus 9. Difference is 1. Sorry, write it down against the other one. Difference of these, 12 minus 8. See, I took 10 minus 9, but this time I am taking 12 minus 8. No issues. 12 minus 8, it would be 4. Take difference of second and write down in against first. Take difference of first column, 12 minus 9, and write it down against this column. Take difference of second column, write it down again first column. Are we clear with this? I took difference of first row, 10 minus 9, put it here. Difference of second row, put it here. Difference of first column, 12 minus 9, put it here. 10 minus 8, put it here. Now add them. How much is this? 2 plus 3, that is 5. Add them. How much is this? 4 plus 1, that is 5. Very important thing. The sum will always be same. If it is not same, either you have done some blunder in calculation or your question is a stable question. Listen very carefully once again. The sum will always be same. If it is not same, there are two possibilities. Either you have done something wrong over here in the subtractions, or your game was not an unstable game, your game was actually a stable game. So, whenever you come across this kind of situation, the sums should be same. If they are not same, you have to go back. You have to go back and check either these sums, or you have to go back a step further. It was a stable game and you misread it. It was a stable game, you misinterpreted it as an unstable game. So, it is your fault either ways. Either it is a calculation issue or it is an identification issue. You identified a stable game as unstable. So, this sum will always be same. And what is the sum in this case? It is 5. So, I will find out the odds in this way. This is it. This is the solution. If you remember, what is our solution? This is our solution. This is additional information. This is additional information for our sake, for our understanding. But this is the solution. What is the solution? I, being a manager, I am telling the team, I am telling the player, I am telling the company to select this with the probability of 0, this is the probability of 1, 0, 1. Select this with the probability of 0 and select this with the probability of 1. So, this is solution of game, and of course value. When I am playing a game, I should know what is the value of this game. So, strategies for A would be 4 by 5 and 1 by 5. Strategies for B would be 2 by 5 and 3 by 5. And value of game would be, you take these odds and multiply them to returns respectively. You cannot multiply them randomly. You need to multiply them respectively. What do we mean by multiplying them respectively? You take these odds and multiply them to returns, payoffs respectively. If you have taken 4 by 5, multiply it to 10. And if you have multiplied 4 by 5 to 10, then 1 by 5 will definitely be multiplied to 8. This is value of game. You take the odds, multiply them to returns. I took these odds, I multiplied them to returns. 4 by 5 into 10, 1 by 5 into 8. Thereby giving me 40 by 5 plus 8 by 5, making it 48 by 5. Now value of game can be found out in n different ways. I took these odds multiplied to these returns. You could have taken these odds and multiplied them to these returns. Let me see what would have happened. If I take these odds, or I can say V can be found out by 4 by 5, 1 by 5. Take these odds, multiply it to these values. 9 and this return is 12. Making it 4 9s are 36 by 5 plus 12 by 5. You get same value of 48 by 5. Which is obvious. When I am giving you a strategy, obviously it is expected that it will give you same returns. How can different strategies give me different returns? If different strategies are giving me different returns, then obviously I will be rejecting the other strategy. I'll be rejecting the poor strategy. I'll be selecting the better strategy. So if you have two outcomes where one value of game is different, one value of game is different, obviously I'll reject the inferior value. So only one will win. And I have come to a point where you may go with any route. You may go with either this route or you may go with this route. You will get the same return because this is not 4, this is 5. You may go through any route. Your return will be 48 by 5, 48 by 5. This does not end over here. You can check it for B also. What are the returns for B? Or you could even go through this. Odds for B are 2 by 5 and 3 by 5. The idea is multiply the odds to returns. 2 by 5 will be multiplied to 9. 3 by 5 will be multiplied to 10. This is 10. You add them. You will get 18 by 5, 30 by 5, making it 48 by 5. The idea is you could go any way, any path, but respectively. Multiply the odds respectively to their returns. 2 by 5 is multiplied to 9, so 3 by 5 will be multiplied to 10. You cannot say 2 by 5 into 9 and this. This is not a respective multiplication. This is a random multiplication. When I say respectively, then first is multiplied to first, second is multiplied to second, and so on. Or one case is remaining, let us check that also. You could have taken 2 by 5 and 3 by 5. And you might have multiplied them to 12 and 8. Thereby giving me 24 by 5. 24 by 5, making it 48 by 5. So we see that whatever combination we pick, the value of game is same. You need not find out all these values. You can find it using any one combination. This is solution for you. I've always been telling you that solution is strategy for row player, strategy for column player, and value of game. Strategy for row player 4 by 5, 1 by 5. Strategy for column player 2 by 5, 3 by 5. Value of game 48 by 5. And what does this strategy mean? Last time I said strategy for row player should be 0 and 1. Thereby I meant that never go with R1. 100% of the times, probability of 1 to R2. 100% of the times, R2. This time what I am saying is 4 out of 5. That is 80% times you should stick with A1. 20% of the times you should stick with A2. This is unstable game. In stable games, I tell you, A2 is the best strategy, B2 is the best strategy. Then we never change it. You come to me after 10 days, I'll tell you, A2 is the best strategy, B2 is the best strategy. But in unstable games, we'll be changing our strategies consistently. But yes, with a bias towards first strategy. First strategy 80% times, second strategy 1 out of 5. And in the same set of 5 games, what does this mean? 4 out of 5 games I'll be going with this strategy. 1 out of 5 games I'll be going with this strategy. We always say that out of n games, over a period of n games, average return will be 14. Over a period of n games, the return will be 14. So here also, over a period of 5 games, 4 times you should stick with A1, 1 times you should go with A2. In the same 5 games, what B2 will be doing, what is suggested to B2? 2 out of 5 B1, 3 out of 5 B2. And what is value of game? Value of game is these odds multiplied by returns respectively. You can take any combination. You could take this combination or you could take this combination, as we saw. You could take it for column player, this combination or this combination. So out of 4, you could go with either of these combinations to get your value of game. So this was Odment method to solve unstable games of size 2 by 2. What we'll do is, we'll solve one more game so that we come into groove. We settle into a groove, we come into practice. So I'll put up a game over here. You can pause the question, you can solve it by yourselves, and then you can tally from here. Let us solve this question. Let us solve this game. Remember, look for stability. As soon as you get a game, look for stability. How do we look for stability? Look for saddle point. How do we look for saddle point? Look for minimax from column player and maximin from row player. If both minimax and maximin are same, you have your saddle point, you have your stability. If the game is not stable, move to Odment method. Let us solve this question. You can pause the video, you can solve this question by yourself using Odment method, and then we'll tell you the answers. What answers you bring and what answers I bring over here. Check for stability. Maximum, maximum, minimum, 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 maximum. In fact, this game is stable. This game is a stable game. So I can say that strategies for A are 1 and 0. Strategies for B are 0 and 1. And value of game is 8. Maximum, maximum, minimum, 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 maximum. I'll write down another question over here. Hopefully that is an unstable one. So let us try this question. Maximum, maximum, minimum, 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 maximum. 9 is pointing here, 5 is pointing at some other location. Look for stability. I searched for stability, I found stability, I gave my solution. Another question, I looked for stability, I could not find stability. Next step is solve it using Odment method. Difference of first row in second row. 11 minus 3, 8. 9 minus 5, 4. Difference of first column over here. Now, important thing, these sums should always be same. 8 plus 4 is 12, 6 plus 6 is 12. We are on right track. Divide all these by that common sum. What is my strategy for A? 4 by 12 and 8 by 12. 4 by 12 and 8 by 12. What is my strategy for B? 6 by 12 and 6 by 12. It is always suggested that we write down on common platform. So this is more intelligible. 4 out of 12 games A1, 8 out of 12 games A2. And in those same 12 games, 6 out of 12 B1, 6 out of 12 B2. Now if you cancel them out, these values might become different. This might become a 1 by 3, this might become a 2 by 3, this will become 1 by 2. So for A we are saying 1 out of 3 and 2 out of 3. For B we are saying 1 out of 2, 1 out of 2. So let the base be same. So this time I am talking of 12 games. So this is strategy. And what about value? Value is odds multiplied by return respectively. 4 by 12 multiplied by 11 plus 8 by 12 multiplied by 5, making it 44 by 5 plus 44 by 12 and then making 40 by 12, making it 84 by 12. This is value of K. Now, I have been laying stress on that these totals will always be same. If these totals are not same, I told you two things. You need to go back. Either you have done some wrong calculation or it was actually a stable game. If calculation is wrong, you can troubleshoot from here itself. But if you have done some other blunder, that is you picked up a stable game 11-8 and 5-3. We have a game 11-8 and 5-3. Let this be B1 and B2, A1 and A2. If I try to find out odds for this, now we know that 11-8, 5-3 was a stable game. If wrongfully, I try to solve it using oddment method, what happens? 11 minus 8, 3. 5 minus 3, 2. Wrongfully. Remember, whatever I am doing is wrongfully, in error. This used to be a stable game. Wrongfully what I am doing is, I am trying to solve it using oddment method. So 11 minus 8 is 3, 5 minus 3 is 2. 11 minus 5 is 6, 8 minus 3 is 5. This sum is 11 while this sum is 5. I told you these sums should always be same for both rows and columns. This was an unstable game. We had a sum of 4 plus 1, 2 plus 3, 5. This was an unstable game. 4 plus 8, 12. 6 plus 6, 12. This was a stable game. You are getting different sums. So if these sums are not same, 5 plus 6 and 2 plus 3 are different, you have messed with a stable game or you have messed with your calculations. Let me check this one. This was a stable game. If I try to solve it using oddment method, what happens? 9, 11, 16, 14. 9, 11, 16, 14. 11 minus 9 would be a 2. 16 minus 14 would be a 2. Difference of these is here, this. Difference of these is here. 16 minus 9 would be a 7. 14 minus 11 would be a 3. Sum is 4 against a sum of 10. Sum of 5 against a sum of 11. So if you try to solve a stable game using oddment method, these sums will not be equal. And if these sums are not equal, what should I divide with? In this case, sum was 5, 5. I divided everyone with 5. In this case, sum was 12, 12. I divided everyone with 12. What do I do now? Sums are not same. So you should always check these sums. If these sums are same, we are on right track. If these sums are different, either the subtraction is wrong somewhere or it actually is a stable game. Fine. So this was our oddment method to solve an unstable game. Oddment method to solve an unstable game of size 2 by 2. Then there is another method, that is algebraic method to solve an unstable game of size 2 by 2. That we'll see in next lecture. For now, we needed to understand this concept, how to find value. How to find value of game. Now, once we know how to find value of this game, now we can move to algebraic method also. So, next time when we meet, we'll talk about the algebraic method to solve an unstable game of size 2 by 2. This was Audement method, we'll talk of algebraic method. So, this was it for our today's lecture. Thanks for watching, bye bye, take care.